Well, good evening everyone. Welcome back again. So today we are going to discuss about angular momentum of a particle. Just in brief, I mean like a little introduction to this, and at the same time we will try to understand it at some ease. Okay. So let us firstly know about the definition of this angular momentum of a particle in words. Then we will go into the formula and all the kinds how to understand this in detail. Okay. So let me write this the definition of the angular momentum of a particle. It is defined as simply see angular momentum of a particle or a moving particle, I can say clearly, about any point. Okay na, so that's what we are going to do now. So angular momentum of a moving particle about any point we are going to calculate. So similarly, while doing the numericals also you need to do the same, right? Is defined as the product of linear momentum of the particle and perpendicular distance of the line of motion from the given point. So this is what your definition of an angular momentum of a particle. So now with the help of a diagram and all, let us try to understand or clearly have an idea about this angular momentum. So for this I would like to just make sure this I'm going to draw a diagram, and now I'm assuming it that a particle was moving in the xy plane. In which plane? Let me repeat once again. It is moving in a xy plane. See like this. So a particle is moving now in an xy plane. So let me suppose this is a particle, and during its path or during its motion, so this is the direction of the motion of this particle. I can say clearly show you the here. So therefore let me suppose it is moving with a velocity v bar and say it is having a mass m. So therefore its momentum is given by m v bar. Done. So now if I would like to locate this particle, I would like to locate this particle in the xy plane. So therefore with what help I can do, already you all know, right? Yeah, that is the position vector. What was that called as? Position vector, or the distance, we can say, location of a particle during its journey. As I said, this is moving, right? It is a moving particle, so therefore I would like to show you the path of this particle also. See, so this is the path of the particle clearly. Done. So therefore now along this path a particle is moving now at a particular point. What is that point? I would like to show you directly there. At a particular point, I am considering the position of that particle. Let me say it is A for time being, for you to understand clearly. So now this position vector is making an angle. Assume that the position vector is making an angle with the motion of the particle. So motion of the particle means I would like to say that is its momentum. So say this angle B, for time being I'd like to consider this one as theta. So therefore from your geometry already you know this is also going to be theta. So now from the definition try to understand. So let me give all the points now. So this is O, this is B, and this is the perpendicular 90 degrees. So what was the definition? Yeah, come again now. So the definition is linear momentum of a particle, L. Linear momentum of a particle is denoted by L. What did I write here in the definition? Product of linear momentum. Very good. So product of linear momentum. And product means there should be one more term. What is that? Another term directly we did. Product of linear momentum and perpendicular distance. What is that distance called? Perpendicular distance. I would like to denote it with a symbol so that it will be easy for me to write over here. Distance from where to where, this perpendicular distance you are saying of line of motion, right? So line of motion. So about a given point, I'm said about a given point mean about here origin. That is about origin. So from the figure, line of motion, sir, which is line of motion, sir? In this you didn't even tell us. Yeah, very good question. So this is your line of motion. So this is line of motion. So now the perpendicular distance of line of motion from or about the given point. See, this is the given point, right? And this is your line of motion, am I right? So perpendicular distance mean OB only in the figure. So OB is the perpendicular distance of line of motion about the point whose angular momentum of a particle is being calculated. So hope you got a clarity now. I need OB finally. So therefore let us derive now angular momentum directly. So therefore L is given by linear momentum in magnitude. I am writing mv, and it is multiplied by perpendicular distance in the figure is OB. So already it is clearly visible that OAB is right angle triangle. Already you know trigonometry, I guess. So I need OB directly now. So therefore I can take only just directly sine theta is equal to opposite side by hypotenuse, that is the magnitude is given by r. So from which I get the perpendicular distance OB is given by r sine theta. Now replace it here. So therefore L is equals to mv into r sine theta. So this is nothing but L is equal to mvr sine theta. So therefore it is there here velocity and position vectors. There are two different vectors are there which under multiplication gave you sine theta, right? So therefore angular momentum is also a vector quantity which is obtained by cross product of r bar cross v bar, m into r bar cross v bar. This also can be written in simple words as r bar cross momentum, that is linear momentum p bar. So this is your angular momentum. So easy to understand, shall I say one word? Easy to understand for you all what is angular momentum here. So in your linear motion, okay, in the linear motion, linear or translatory motion, linear momentum is there, right? So it is similar to that of linear momentum in translatory, that is angular momentum in rotational dynamics. So I would like to write L bar. So here I am writing L bar, that is angular momentum in rotational dynamics, where in rotational dynamics is similar to, okay, so is similar to, or you can say analogous to, also you can say similar to linear momentum in translatory motion. That's it. So easy to understand for you. So therefore in a linear or translatory motion, whatever the role of linear momentum will take, the same role angular momentum will take in the rotational dynamics. Clear? And as usual, simple like a cross product have came into existence over here, right? So therefore I would like to give you directly the direction of angular momentum. Okay na? So direction of angular momentum can be explained by the cross product rule. So what is that cross product rule? Right hand thumb rule. You can use the help of right hand thumb rule to understand the direction of angular momentum. So this is one thing I would like to show you. And sir, there are system, it is a system, I am having a system, and in that system there are n number of particles. There are n number of particles. So for every, pour in everything directly, for all particles, if I would like to calculate the angular momentum, sir, how to do? Then you can directly do summation. L bar is equal to summation of I equals to 1 to n Li bar. So sum of all angular momentums of each and every particles present in a system gives you the total angular momentum of that system. So directly I would like to write I is equal to 1 to n r bar cross pi bar. So this is the formula you can use. And as usual, we already have an habit of writing units, right? So for every physical quantity. So let us also write the units for this physical quantity. What is that? Angular momentum, and it is given by in CGS system. Straight away I would like to show you gram centimeter square per second. This also can be written as gram centimeter square second inverse. And as usual, we already know in SI system we would like to follow that one. So that is kilogram meter square per second, or kilogram meter square second inverse, and this is also in terms called as joule second. And if you had a habit of writing dimensional formula, and let me give you the dimensional formula of this physical quantity angular momentum, that is m L2 T minus 1, and you already know that it should be enclosed in a braces. So this is all about your angular momentum of a particle about a given point. So I would like to repeat once again, that is the product of linear momentum of a particle into, that's what, product of this linear momentum and the perpendicular distance of the line of motion of the particle, from where this perpendicular distance should be taken about the point whosever angular momentum you are going to calculate. Hope you all got it understood. So thank you, have a great day. Any doubts, please post in the comment box. I was always ready to explain you. Thank you, have a great day, guys.